called interleaved memory. Remember, interleaved memory is a special type of memory in which the main memory is divided into two or more sections or blocks or modules. So, the main memory is divided into two blocks B1 and B2 or sections S1 and S2 or modules M1 and M2. So the main memory is divided into two or more sections. The CPU can access these alternate sections or blocks immediately without waiting for memory to catch up through wait states. So the goal of this interleaved memory is that CPU can able to access these memory modules immediately. So interleaved memory is one technique for compensating for the relatively slow speed of the dynamic RAM. So the interleaved memory is one technique. Interleaved memory is one technique for compensating for the relatively slow speed of the dynamic RAM. So let us understand this concept first. If this is my main memory, the speed of the main memory is very much low when you compare with the speed of the processor. So when I say processor, it is a combination of control unit, ALU, and some registers, and also sometimes cache. These are all called interleaved memory. This is called a processor. So the processor is a combination of control unit, arithmetic and logic unit, and some registers, special purpose registers, and also cache memory. So here what's happening, the speed of the processor is very high when you compare with the speed of the main memory. So to compensate the speed differences, the compensating means we should improve the speed of the main memory. We are employing a cache memory, and still there is other technique with which the speed of the main memory can be improved is by using a technique called interleaved memory. So interleaved memory works by dividing the main memory into some blocks or some sections. Memory interleaving with memory interleaving or interleaved memory, what happens, it increases the bandwidth by allowing simultaneous access to more than one chunk of memory. So what happens here with dividing interleaved memory, interleaved means dividing the main memory into two parts. Simultaneously the M1 and M2 can be accessed. So this is the major advantage of memory interleaving. So with the memory interleaving, what happens, it increases the bandwidth by allowing simultaneous access to more than one chunk of memory. So this improves the performance because the processor can transfer more information to and from memory in the same amount of time. So what's happening, it improves the interleaved memory. With interleaved memory, what happens, one can access one can access the memory modules simultaneously. With that, what happens, the performance of the main memory will get increased. How? Because the processor can transfer more information to and from memory in the same amount of time. So that is the biggest advantage of interleaved memory. And memory interleaving increases the bandwidth, and also it improves the performance. Interleaving works by dividing the system memory into multiple blocks. As we know, interleaving means dividing the memory into some multiple blocks. The most common numbers are 2 or 4, which are called two-way or four-way interleaving. That means the main memory can be divided into two parts, M1 and M2, or the main memory can be divided into four parts, that is M1, M2, M3 and M4. So this is called two-way interleaving, and this is called four-way interleaving. So one is called two-way interleaving and other is four-way interleaving. So each block of memory is accessed using different set of control lines which are merged together on memory bus. So here you should understand 2 points. One is control line. Each block of memory or each module in the memory can be accessed using a different set of control line. That means each one has a separate control line. So first you should understand what is meant by control line. Remember a special unit in the processor which is called control unit. The job of the control unit to send some control signals to main memory input and output devices and ALU to control their functionality. So what control signals the control unit can send to main memory means which operation is required to perform by memory operation, whether it is a read operation or write operation. How it sends, let's take, if it sends 0, if the control unit sends 0 to main memory, it is a read operation. If it is a 1, it is a write operation. So the goal is the control unit sends different different sets of control lines. So if I divide the main memory into two modules, let's assume M1 and M2, and I call this as a two-way interleaving. And remember, there is also another type that is called four-way interleaving, and this is two-way interleaving. For this two-way interleaving, the control unit uses two separate control lines for sending the control signals. So each memory module acts like a separate main memory. So when I say each memory module has a separate main memory, each one should have a separate control line. And remember, control line sends some signal to the memory module which gives an information which operation is required to perform, whether it is a read operation or write operation, which operation is required to perform. Next, when a read or write is begun on one block, read or write to other blocks can be overlapped with first one. So this is the major advantage of uh, memory interleaving. Let's assume I divided the main memory into two modules, M1, M2, and this is my processor. When processor is issuing address 1, when processor is issuing address 1, this is my main memory, which is divided into two parts, M1, M2, and this is my processor, which issues an address 1 and address 2. So when a read and write operation is begin in one block, a read and write operation in other block can be overlapped with the first one. More the blocks, more the overlapping time. That means if this operation requires 10 nanoseconds and this take 10 nanoseconds without memory interleaving, 10 plus 10, it takes 20 nanoseconds. But with this memory interleaving concept, in just 10 nanoseconds, both operations can be performed because they are performing simultaneously at the same time. So this overlapping increases with the number of blocks. The more blocks, the more that can be overlapping can be done. As an analogy, let's take an example. Consider eating a plate of food with fork. The two-way interleaving would mean dividing the food into two plates and eating with both hands using two forks. So let's assume he's giving a small example. So divide the food into food 1, food 2 into two plates. This is plate 1 and this is plate 2. Now you should eat with both hands parallel. Here the processor is eating and it is much faster than the forks. So I'll give one more example to make you a clear understanding of the need for memory interleaving. Let's assume there is a textbook which is main memory. This has to be shared by a group of people, and one way of sharing is first person can access the main memory or textbook. Once he completes, then the second person can access. This goes on. And the other way is divide the textbook into different modules or different blocks, different parts, like two chapters in one block. And if you now you can share this textbook to three persons at a time. Similarly, if the main memory is divided into different modules, what's happening here, you can uh, able to access these memory modules at same time or simultaneously. So this is one biggest advantage of the interleaved memory. And in interleaved memory, each module has its own address buffer register and data buffer register, and the memory access operations may proceed in more than one module at same time. So let me give an idea. If this is my main memory, which is divided into two modules, this has a separate register, address buffer register, and data buffer register, address register 1, data buffer register 1, and address buffer register 2 and data buffer register 2. Here sits my control unit, which is part of processor, and it can have a separate control signal. So with this separate control signals, what happens means it has the memory mod. The advantage of having its own or separate address buffer register and data buffer register for a module means they can be memory read or memory write operations can be performed independently without depending on one memory module other memory module. Now let's look at some diagram which represents the interleaved memory. So here what's happening, address the memory main memory address. See when processor issues an address, you call it as virtual address, and when you map this virtual address, it is converted into physical address or main memory address. Remember the concept called virtual memory organization, where the address issued by the processor is called virtual address, and there is a mapping technique. When you apply some mapping function on it, it is converted or translated into the main memory address. Now this main memory address is divided into two modules, two parts. The higher order k bits, are uh, used to identify the module in the memory. So can you guess how many modules then the main memory might be divided into, with k bits being assigned as a address to identify a module? See, k bits are used to identify a module. That means there are 2 power k modules are present in main memory, or the main memory is divided into 2 power k. And what about their address? First memory address is 0, the last memory module address is 2 power k minus 1. Next m bits are reserved to identify a word within the module. So the next m bits are used to identify the word in a memory module. Can you guess, with the 2 power k modules, there are 2 power k modules, and m bits are reserved for identifying a word in the module. Each module might contain how many words? Means 2 power m words. So the each memory module contains 2 power m. Here 2 power m means starting from 0 to 2 power m minus 1. 0 to 2 power m minus 1. These many number of words are present in the memory module. And see, these are the control lines. Control signals or control lines that are transmitted to each memory module. So each memory module has its own data buffer register and its own address buffer register. So ABR stands for address buffer register, DBR stands for data bus register. So interleaved memory. In the first case, the memory address generated by the CPU, the memory address generated by the CPU is decoded as shown in the figure. The higher order k bits name one of the n modules, and the lower order m bits name a particular word in that module. When consecutive locations are accessed, as happens when a block of data is transferred to a cache, only one module is involved. This is interesting thing. That is, if this is my memory module 1, this is memory module 2, this memory module 3, and what's happening, right, cache works on the principle of locality of reference. So the locality of reference says that there are two types of locality of references. One is temporal and other is spatial locality of reference. Temporal says that when you access a particular word in the memory, and in the near future you may expect that in near future you may again access the same word, so keep that word in the cache, which is called temporal locality of reference. And there is other technique called spatial locality of reference, where when you access a particular word, then its nearby words are transferred to cache memory with an expectation that you might access those words in the future. This is called spatial locality of reference. The the cache works based on the principle of locality of reference. First, you should know that these memory modules now should support the cache. How they support the cache means, if they if one memory module contains all array elements or array elements starting from a of 0, a of 1 to a of n. If a single memory module stores all array elements, then the entire array elements can be transferred to cache. Similarly, if a particular memory module contains the body of for loop, in the entire body of for loop, then this can be transferred to cache very easily without involving in other modules. Only one module is involved, other modules are not involved. Similarly, if this is my one memory module, if it contains a subroutine, then this can be transferred to cache at same time. So this is an advantage of this is one advantage of memory modules. If the memory module follows the principle of locality of reference, it is well and good. Next we see that at the same time, however, devices with direct memory access, the ability may be accessing information in other memory modules. So here we have a special word called DMA. DMA stands for direct memory access. So what is this direct memory access means? So this direct memory access refers to, it is a one kind of processor or dedicated processor, or we can call it as a dedicated data processor, which is used to it's a dedicated data processor and its job is to the job of DMA or direct memory access. The job of direct memory access is to transfer huge amount of data or bulk amount data from input device to main memory, or transfer the huge amount of data from main memory to output device, input device or output device. So this is the goal of DMA. Remember, DMA is a special type of processor or special kind of processor, and this processor is used. It's a special type of processor or special kind of processor, and this dedicated processor is used to transfer the data from input device to main memory or from main memory to output device. So DMA is like one more processor, but it's called dedicated processor, and its job is to transfer the huge amount of data or bulk amount data from memory to IO devices, from or to memory to IO devices. Now what happens, being dividing the memory into two memory modules, that is memory module 1 and memory module 2, which is called two-way associating memory. The processor can access one memory module, whereas DMA can access another memory module. So this is the advantage. When a processor accesses one memory module, the DMA can access other memory module, that is memory module 2. So this is the advantage of dividing the memory into two parts or two sections or two blocks, which are called interleaved memory. Next, we will see that in some cases the main memory address can be divided into again two parts here, but this time the higher order m bits are used to identify a word, and the lower order k bits are used to identify a module. So the higher order m bits can be used to identify a word in the module. The lower order k bits are used. The higher order m bits are to identify a word in the module, and the lower order k bits are used to identify a module in the main memory. So this is called another type of configuration, and this is more effective way, because what's happening with this method, the second and more effective way is to address the module shown in this figure, which is called memory interleaving. Here the lower order k bits of the memory or selects a module, and the higher order m bits name the location within that module. So with this, the advantage is that it leads to accessing consecutive consecutive addresses located in successive modules. So even if consecutive addresses are assigned in successive modules, let's assume, so this is array 0 and array 1 is accessed or stored in memory module 1, and module 0 contains you have 0. Yes, you can access these successive memory locations with this type of memory being divided. Let's discuss about a new topic. This is called input and output organization. So we all know some example of input and output devices such as keyboard, mouse, right? So what is there to organize means, yes, there is a lot of thing to discuss about input and output organization. So the input and output organization of a computer depends upon the size of the computer and the peripherals connected to it. So, so the IO organization of a computer depends upon the size of a size means what is the hard disk capacity, what is the RAM size, and what is the speed of the processor, like that. And what are the peripherals connected to it? Peripherals in the sense they are also input devices. Peripherals are also called input and output devices. So the IO subsystem of a computer provides an efficient mode of communication between the central system and the outside environment. So you should understand that if this is my computer and these are IO devices, all IO devices. So there exists a special system which is called IO subsystem. So this IO subsystem provides an efficient communication between the processor or hard disk or RAM to external environment, that is IO devices, input and output devices. So we should learn in detail, we'll discuss in detail about uh, this IO subsystem. So we will discuss in detail about how this IO subsystem works. So remember, once again I will draw, this is my computer and these are the external IO devices. There exists a subsystem called IO subsystem. So this IO subsystem is very important in all aspects. Let us look at some peripheral devices. So the peripheral devices are an external device connected to an IO module provide a means of exchanging the data between the external device environment and computer. So peripheral device is an external device connected to an IO module or IO subsystem. So these are called peripheral devices which are connected to IO module, which are connected to computer using IO module, and the goal is to exchange data. So the goal of these peripheral devices, they should able to send the data to the system and receive the data from the system. For that we have a special module called IO module. attached to any computer by a link to an I/O module. So these peripheral devices are attached to a computer by a special link to an I/O module. This link is used to exchange control, status, and data between I/O module and external devices. So attached to computer by a link to an I/O module. That means if this is my computer, this is called I/O module, and they exist, and this is called peripheral devices. So this is an external device which connects to I/O module by using a special link, and this link is used to exchange the different types of information, such as it is used to exchange the control information, status information, and data between I/O module and external device. So examples for peripheral devices are um, keyboard, mouse, joystick, scanner, printer, like that. We'll discuss in detail about that. So remember, a peripheral device means it, it can't directly communicates with computer. It connects to an I/O module. An I/O module can be a software or hardware or both. It connects to an I/O module for exchanging the data between computer and these external devices. So first, this peripheral device connects to an I/O device or I/O module, and that connection is called, we are giving a special name called link. And these are the example of peripheral devices that we already know. Monitor, earlier we used to have CRT monitors, and now we have LCD monitors. So all of you know about various peripheral devices such as monitor. Monitor is an output device, first thing everybody know. An example are CRT monitor, cathode ray tube. They have become obsolete now. LCD monitor and even LED monitors. So LCD stands for liquid crystal display and LED stands for light emitting devices. So these are the example for monitor. Monitor is an output device. Keyboards. Keyboard is an input device. There are different types of quartz keyboard. Different types of keyboards are available. Next, we have mouse. Mouse is also an input device. We have optical mouse, wireless mouse. So many different kinds of mouses are available in the market. And printer. Printer is an output device. Earlier we used to have dot matrix printer. Now laser printers have come. So like that we have, as the technology evaluates, there are different kind of devices. And magnetic tapes. Magnetic tapes are the external hard disk example. So these are the uh, examples for peripheral devices, and there are some more peripheral devices such as joystick. This joystick is an example of an input device. Scanner. Scanner can be an I/O device. It can both act as it acts both as an input device and output device. And speaker, USB drive. So USB drive is also acts as an input and output device. Of course, speaker acts as an output device. So these are the examples for different types of input and output devices. So three categories of external devices: human readable, machine readable, and communication. Human readable, suitable for communicating with computer, user video display terminals and printers. There you can read the content. For example, you can read the content that is displayed on the monitor. That's what we are doing right now. Another thing is printer. You can read, understand or read the content of the printer. And machine readable, suitable for communicating with equipment, magnetic disk, tape system, sensor, actuator. Actuators are like they take the accurate measurement of temperature. Communication. Communication external device. Example for communication type of external devices. They are suitable for communicating with remote devices such as terminal, machine readable device or another computer. So these are called different types of peripheral devices. Now let's look at some block diagram of an external device, which is very important to understand. Uh, the thing is, here the block diagram of an external device means maybe any external device. It should contain a buffer, transducer. It contains buffer and transducer, so that, see, this is called link. This link is used to send data bits to and from IO module. So this is most important. See, when the data goes from IO module, first it has to be stored in the buffer part of, it has to be stored in the buffer part of the external device. And there is a logic for each external device. There is a control logic which receives control signals from IO module. See, the IO module sends a control signal to the control logic, and this IO module will send the status signal. So three type of data is exchanged between this external device and uh, external device and IO module. That is control, status, and data. So here what happens, here you should understand thoroughly about this. First, data device unique, data to and from environment. That means user sits here. When user enters the data, or user can get the data. When user enters the data, let's take an input device such as keyboard. When the user enters, types the data, that will go to transducer, and finally it goes to buffer. For example, if you type a name called Nabi, this ultimately goes and stores here this data. Now this data has to be transferred to IO module using special link based upon the control signal received from IO module. So the control signal, who controls the IO module, controls the external device. The IO module sends a control signals to this external device, Then this control logic should send a status signal whether the particular external device is ready with the data or user has entered, because it depends upon the user. If the user doesn't enter the data, even if IO module sends a control signal, there is no point. Only the external device sends a status that still I have to receive the data. Once the user enters the data, upon receiving a control signal from input devices, it will send a status signal saying the data is ready. Then he sends a control signal, send the data. Then the data has to be sent to IO module by link. So this is how external device works. So we'll again see what are the different components. Here sits the user, enters the data, input the data or output the data. If it is an input data, it goes to transducer, and finally it goes to buffer. Then it sends a control status signal that data is ready. Then it sends a controls IO module sends a control signal, send the data. Upon requesting getting a control signal, external device sends the data stored in the buffer to IO module. So this is the typical block diagram of any external device. Now let us discuss an important topic, that is IO interface. So IO interface is called input and output interface. So far we know IO module. Right now this is a special new term called IO interface. This IO stands for input and output interface, provides a method for transferring the information between internal storage such as memory and CPU registers and external IO devices. So far we know that we are saying computer, computer, computer. So what computer contains? The memory. The computer contains processor and memory. Right? This memory means it can be main memory or CPU registers. Then this is called IO module. These are called peripheral devices. Now what is this IO interface means? It provides a method for transferring the information between main memory or registers to peripheral devices. So from now onwards we will call this as the internal storage. Internal storage means it can be main memory or registers. Remember that. And external IO devices. These are called external IO devices. So internal storage and external IO devices. Peripherals connected to a computer need special communication link for interfacing them with the central processing unit.